And we're back.
Welcome back to the Road to Code.
That's right.
Episode 4.
Is it really episode 4? It is.
Yeah, we've been doing this for technically a month now.
I know. And today is Super Bowl. I saw halftime show. How much of the game did you see?
Yeah, I got up to the point of the halftime show, and then I was like, all right, I think it's pretty good. Pretty good game. Super Bowl.
Yeah. The commercials are always good. So.
I'm more about the food.
Yes. The food is always good. It is. I know. I had a burger while I was watching the halftime show. So. Cool. So it's week number 4 or episode number 4. And so technically you have been working with C# for 3 weeks now.
Yep.
Because the first week you barely got the book.
Yeah,
so
it was the intro.
It was the intro. So yeah, so this is how do you think it's going?
Right now I feel like maybe this chapter 3, I felt like I was in the code.
Nice.
That's what I felt like. The rest was just like beginning, but I feel like I'm getting into it. Like I got my feet into the pool now.
Nice. Cool. The analogy that we can use is when you were little, we took you to go learn how to swim. And I think it took like 2 or 3 years for you to actually learn how to swim over at the public pool. But I think the first year, and granted, I think you were only like 3 or 4 years old. The whole point of getting you comfortable with the water is that you would feel comfortable with your face under the water and be familiar enough to hold your breath or at least blow out and not breathe in. And so one of the first steps that they had you do was blow bubbles into the water. And so this is like the first step.
Yep.
To feel comfortable getting into the water and start getting your face into the water. And so do you feel that it's like blowing bubbles into the water or a little bit more than that?
I feel like it's a little bit more because
all right.
C# could get pretty complicated.
Tell me about it. Very cool. Let's see. How does it compare to JavaScript? Let me ask you this question. Not so much how it's compared, but do you feel like it's made you a better JavaScript developer?
I think I understand a lot of the kind of like the classes or the just like the different types that I use more now because they have like definitions instead of just writing random types and stuff.
Okay. All right. That's a fair assessment. That's fair. Okay, cool. Yeah, I think when because I started with C#, well, I started with other languages, but when I got into C#, I wasn't much of a JavaScript developer. And when I got into JavaScript, I began understanding C# better. And so it was interesting just seeing the perspective of a language from a different language, a perspective of programming from a different language. So it was kind of cool to learn JavaScript, and I was like, oh, I had something that I can compare side to side and understand C# a lot better. So so yeah, hopefully that'll come to you at some point. And so cool. I personally learned 2 things. Yeah, I think I learned 2 things. 2 things that I did not know about C#. And so I thought it was kind of cool. And I was like, hey, it's good to know this. When we get to those, we'll cover it. But just by reading, I knew I was going to learn something. I just didn't know to what extent. But it was kind of cool. Pick up a couple of nuggets of logic.
Yeah.
Cool. All right. Well, take it away. Show us what you got.
Right. Cool. Yeah. So the chapter starts by talking about operating on variables. Um, so how to kind of just like I feel like it just basically counting in the beginning, just counting integers, numbers only. So incrementing by one digits and stuff like, or by single digits or double digits.
Yep, yep.
Um, and yeah, that's when I first realized I was like, oh yeah, I'm in the code now. I'm manipulating computers with ones and zeros.
That's right. Incrementing by ones. Based on what you've learned in the last two chapters, chapter 2 and chapter 3, how much math do you think a programmer needs?
um, I based on the last two chapters, not a lot. It's pretty like just addition, subtraction, multiplication, division kind of thing.
Okay.
That's about
Good.
it.
Yeah, yeah. Yeah, I don't feel that there's a whole lot of math. I mean, I've done some pretty high level websites, some pretty complex applications, and I mean, there is some complexity to the math, but it's not like you need to learn trigonometry and math
Calculus or anything.
analysis
Yeah.
or advanced algebra. I do think that people who people who create a programming language probably should have that level of math. Um, People who create like drawing applications and stuff like that, I think that level of math is pretty
Yeah.
important. But yeah, no,
Or,
I mean, I
or
I
with
haven't.
the photo editing, a lot of more complicated math would probably go into that too. Because
Yeah, yeah, yeah,
yeah.
definitely. Photo editing, even some of the gaming, I can see where you're trying to calculate physics.
Yeah.
I can see that. I can totally see a lot of math going into that. But for your typical business application, there's really not a whole lot of math going on. Maybe some statistics for some predictability, like Amazon sharing products that other people are buying, maybe some
Mhm.
statistics on that sense. Um, but yeah, I mean, just your typical business application, even your typical shopping cart, which is fairly complicated. Um, yeah, there's not a whole lot of math, I think you need to know your basic addition, subtraction, your multiplication, your division, maybe some rounding if you're going to be working with money, and the modulus operator, which is instead of how you get a remainder when you divide
Mhm.
uneven numbers and stuff, and you want that remainder. Um, the modulus operator would be as complicated as I seen it get. At the end, there's a little puzzle that they talk about at the end of the chapter. I think it'd be good to. It's a very popular interview question, and so it was interesting. All right, go ahead, take it away.
Yeah. So yeah. Do we want to do any examples, or should we just keep talking about it?
Do you
Um.
have do you have some examples worth?
Oh yeah. Well, this one's just in incrementing by single digits. Probably wouldn't need to show it unless.
Yeah, I mean you're talking about the flow control, right?
Yeah.
Yeah, yeah, yeah. Yeah, the flow control. I let's back up a little bit. Um, the I was a little disappointed with the explanation of conditional uh, or logic operators.
Okay.
He spent such a big amount of time talking about logic operators, and then a quick a quick paragraph on conditional logic operators. And I thought, wow, I was like, that's such little bit. He devoted like a page and a half to logic operators and then conditional logic operators. It was like one paragraph. And I thought, 90% of your code, when you're talking about conditional logic, that's what your program is going to work on when you're trying to control the flow. Very few times will you be using just the logic operators alone. And so I was surprised that he didn't spend more time. But to his credit, when you're working with conditional logic operators, it's a true or false, right? And if you're familiar with true or false tables, then you pretty much, just you execute the condition until it's, if it's true, or you stop executing if it's false, And so I guess because of that, it's pretty simple, but at the same time can sometimes trip you up. I wish he would have spent a little bit more time on that, and so that's the one thing that I wish he would have done. But it is what it is, and you can always Google the rest of the stuff. So,
Mhm.
but he did touch on bitwise and binary shift operators, and this is actually a really, really good point. Let me share my screen. Let me bring up Excel, because there was something interesting that we covered last week. And while Excel's coming up, I wanna acknowledge something from last week. Last week, I did say I was gonna look into the floating point stuff,
Mhm.
and I did check into it, but it was just a rabbit hole that it ended up going down. And so, what it came down to be is that, we covered it last week, and I'll cover it a little bit right now before we get into the bit shift operators. But it really just comes down to working the same way as the way we did bits last week. All right. And so you were back at controlling the flow of the application.
Mhm.
And so as you were working through the different control statements, which one stood out to you most?
Or if else,
Okay. Yeah, yeah.
I could see that being used a lot because they can just keep going. Like I see it in my head. I imagine like a role playing game, like Dungeon and Dragons, like the old school one where it's just typing.
You know what's even a better analogy? Um, Comedy sports. When you went um into that role, you pretty much had a script that you were going to follow, but you were just going to replace
Hmm.
what the audience was giving you, right?
Yeah.
And so, depending on what they gave you, that's probably where your role was going to go.
Hmm.
So, the if statements are similar to that. It's like you're going to execute this piece of code if that if statement is met. If that if statement comes out to be a true, that's the piece of code that you're going to execute.
Hmm.
And so it's conditional, right? And that's for that one time execution. Start at the top, go to the bottom. There's a couple of if statements that will tell you, these are the pieces of code that you'll execute if that condition comes out to be true. Otherwise, skip that code altogether.
Hmm.
So that's kind of what came to my mind as we're talking about the if statement.
Yeah. And then there was just different statements that they used to continue on with the flows, like switch to.
Yep.
They use switch to um, kind of like, yeah, if there's like another flow, like it would switch to something else.
Yep. Yep. Yeah, the switch statement is one of the first ones that took a change. So I think he was talking about C# version 8, where they started using Lambda expressions.
Hmm.
And lambda expressions are basically you're eliminating the brackets and you're using the fat arrow function, what they call the equal greater than sign. I call it a fat arrow. I don't know. Just looks like a fat arrow to me.
Yeah, that's what I call it too.
And then whatever value is executed after that fat arrow is being returned. And so it kind of saves some code because most of the time that's what you're doing in a switch statement is you're returning some type of value from there. And so yeah, so it's that one right there. I was like, oh, I learned something new. So that was one of the things that I learned.
Yeah, you talked a lot about the switch statements.
Yeah, yeah. The switch statements are probably, you know, I think it'd be good to show an example of the switch statement.
Okay.
Yeah, bring up your virtual machine.
All right. This was our old one. Cool. We can start here.
Cool. So I think that there is a let me check really quick. Daytime, day of week, okay, yeah, yep. So yeah, let's go ahead and do a switch statement.
Okay.
And let's switch. Yep, there it is. So we're going to switch on. So go back to that switch on.
Okay. Switch on.
And let's replace that with day of week. I think it's going to be a capital D-A-Y. Yeah, it's it, capital D-A-Y, yep. And this happens to be the days of week. And so we'll start with, go ahead and put your first case in there.
So it would be Monday?
No, so type in case. Case space Sunday.
Sunday.
Because the day of week actually starts on Sunday.
Yeah.
And then the colon. And then you can do a console write. Go ahead and start a new line. And then, yeah, just go ahead and open up your parenthesis and then do the $sign and then double quotes. There's no space between the the $sign and the parent double quotes. Yeah. So in here, you can just say today is.
Oops. Sunday. Or just today is.
And then, yeah. Oh, actually, you would say today is, and then inside curly braces.
A next line or?
No, right after the is.
And then, oh, okay, that's where I put the.
Yeah, we're going to use string interpolation.
Oh, hello. Today is. Why is this button not working? Okay. I need to clean my keyboard or something. Okay.
Yeah, and then put you're going to put day of week dot Sunday. And then close your, yep, there. And then don't forget your semicolon. Semicolon's at the end of the line.
Oh, no.
And then you need to break. So on the new line, break, and then semicolon. So the break essentially just indicates that this is a, actually this is the word break, not the HTML break. And then, and now the custom is that the 2 lines after the case are also indented. So you can highlight the 2 lines and then just press tab and it'll.
Okay. I just deleted them, right?
No, indented one more.
Oh, got you. Yeah.
Yeah. So then let's go with the next case. We'll do Monday, Tuesday, Wednesday, Thursday. So you can copy those and then just copy those 3 lines and then just paste them 6 more times and then we could just replace. So this was pretty painful, even to watch. Let's go ahead and minimize your virtual machine and open up Visual Studio. Yeah, I think you're gonna see Visual Studio is gonna help you a lot more. I think Visual Studio Code is good if you're familiar with C# already, because there's a lot of syntax help missing. Yeah, go ahead, you can do it in there. All right, so just replace that right there with switch. Switch. And then tab twice. And then you're going to switch on day of week. Highlight it. Day of week. Yep. You could just press tab. All right. So get rid of the switch as well. I'm going to show you a trick that happens in Visual Studio. Okay, type in switch and tab twice. Okay, before you move it, just type in day of week. And when it comes up, tab again.
Tab.
And then press enter.
Whoa, that was fast.
You see the power behind Visual Studio? And this is the things that Visual Studio Code doesn't do for you. And so I would imagine that there's plugins. I'm sure there are things that you know people have created. But let's go ahead and after Sunday, press enter and then type in console right line.
Well, before the break though, right?
Before the break, yeah. Oh, let me show you another trick. Go ahead and get rid of console. Type in CW tab.
What?
And then just type in your $, your double quotes. And then just type in today is, and then inside of your curly braces. Okay, so right where you're at, okay, just type Control C. This is going to copy your whole line, and then go down to day of week Monday. I'm sorry, to the break below day of week Monday, and just Control V. And then just keep on doing it to the other ones. Go down to the break, Control V. Oh, now we're cooking with fire. And then just go and replace Sunday with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You can just double click on that word. There you go. Yeah, the first one. That's fine. Double click on it, Tuesday. It just knows.
It does. It knows my brain.
It's a lot more predictable. So at the top, before the static, let's add a new line. Before the actually before the switch, I'm sorry. So on line, add a line after, yeah, after 8, yeah, right there. Just say var dow equals date time, capital D, capital T. Yeah, dot now. Dot day of week. And then semicolon. And then inside the switch, replace the day of week with DOW. Yep. Let's run it, see what it is.
All right. I haven't gotten to the cons or the terminal yet.
Oh, no, you can just hit, you see a little play button up on top?
Oh. First app.
Yeah.
Oh, it came up on this side.
Yeah, bring it on over here to this one. So, oh,
Oops,
where'd it go?
Sorry. Today is Sunday.
So you can see where we got the day of week from the current date time. This happens to be the day of week, Sunday, Monday, Tuesday, all that stuff. What it happens to be, it's called an enumerator, which means that they've assigned a number to each one of these. And because of the name of the number that you've given it, so you said, hey, this is an enumeration. Let's do something here. Go ahead and right click on my first, go ahead and you can just close this terminal. And right click on on first app, and let's create an enumeration. Over on your right, under solution, yeah, right there. Right click and then add.
Add.
Right in the middle, yep. And then we're going to add a class at the bottom. And we're going to give this name. Let's give this name. Oh, what can we call it? Let's call it book chapters. And the class itself, you see where it says class on line 7?
Mm-hmm.
Let's replace that with public space enum. And the way you spell enum is E-N-U-M. There you go, enum. And then after line 8, so add a new line.
Mm-hmm.
And we're going to say, so if we're talking about books of a chapter, right? Or yeah, chapters of a book, right? Normally chapter 0 is like a preface.
Yeah.
Right? So let's type in preface. And then comma, and then press enter. And then chapter _1. The word 1.
Oh.
We'll just do 3 chapters. And then you need a comma. Now, go ahead and save this. No, you don't need a comma at the end.
Okay.
Go ahead and save this, and let's go back to program CS. And let's replace all your code here with var chap. Yeah, go ahead and get rid of the switch as well. We're going to do it all over again. And then we'll call var chap.
Var chap.
Yeah.
Whoops.
Equals book chapters. Yep. Dot preface. And then, yeah, so semicolon. And you're going to do CW tab.
On the next line?
Yes, on the next line. Yeah, at the end of every colon, it's always going to be a new line.
Okay.
And so in here, we're just going to go ahead and write the console chap. Just go ahead and write it out to the console chap. And then on the next line, we're also going to do another console write line. And we're going to do inside of parentheses, type in int for int. You need parentheses around that. So you got your parentheses for the right line.
Yeah.
You need additional parentheses for the int. And then type in chap again. Outside the parentheses, sorry. So we're going to cast it.
Okay.
And those two need to go together. So no space in between.
No space.
Yep. And let's go ahead and run this, see what we get. So you can see where we get the name of the property in the enum, right? Which is preface. But the integer value happens to be 0. So what this is, this enum is just saying, these are just numbers that we're going to associate with words, just like you can with day of week. You can go and create your own numbers and associate those with words. Does that make sense?
Okay, yeah.
And so it's just an easy way, instead of having to remember like, oh, what did 1 represent here, or what did 10 represent here? Like, you don't have to worry about that, right? You just say, I'm just gonna associate these numbers with words. And it'll be easier for a developer to be able to use the words, because words are more meaningful than numbers. You know, the number 1 can mean something in a different context. It'll mean something else. So if you associate the words, you know, here, when we compare the book chapters with the day of week, 0 represents Sunday. Here, 0 represents preface. Imagine if you had to say, wait, what are we talking about? Are we talking about day of week, or are we talking about book chapters? How confusing would that be inside the program?
Yeah.
So instead, what you do is, when you associate these numbers with words, you're putting a context around it by naming the class and saying, this is book chapters, and here are the numbers associated with the values from book chapters.
Interesting. It just makes it easier for the computer to read, though, right?
The computer does not give a rat's ass. It's the human that needs to be understanding of what it means. Otherwise, you will end up creating all kind of problems and stuff when you write your code. So a couple of things: when you're creating a class, you can go ahead and kill this terminal. When you're creating a class, it's better that you don't put spaces in your file names.
Okay, yeah.
So you can right click on
that.
You can right click on it and rename it. and get rid of the space. Get rid of the space.
Just all together. Okay.
Yep. Yeah, this is normally how you want to do it. It's called Pascal casing.
Mm-hmm.
And so if you open up that class, you can right click on the enum, rename it. The book chapter, sorry, the enum book chapters. Rename it and get rid of the underscore.
Okay.
And then press enter. And look what it did to your program. Go back to your program. Oh, no semicolon. Yeah. Look what it did to your program. Go back to program. It renamed it there too.
Cool.
So Visual Studio actually does a lot of neat things like this. And so I personally prefer to use Visual Studio because of all the features that it introduces. Visual Studio Code isn't quite there yet when it comes to developing. I think it's good if you're trying to memorize a language and memorize how you write the syntax. But if you want to see how it should be done, Visual Studio will guide you through that. I wouldn't be able to use Visual Studio Code to write a C# program because I'm spoiled and I'm just used to Visual Studio just helping me with all these little things that I don't want to spend time doing.
Yeah, I could see that too. There's a lot more shortcuts in this one.
Exactly. So what I would recommend is start using Visual Studio to do the examples and see what you can do with that.
All right, sounds fun.
Cool. What else do we got?
Then we go into find where we're at. Then it goes into a for each statement.
Yeah.
For some of the iterations.
Yeah, on the surface, for each is very cool. As a user of a for each, it makes life so easy. But to create an object that can work with the for each, it's somewhat of an advanced topic that gets covered later. And he actually got into interfaces and all this good stuff. And so just to kind of clarify what an interface is, okay? Jonathan, if I say, son, come and paint the outside of my house, I'll give you $200. You'll say, done, Dad. It's like, I'll do it. When do you want me to do it? I was like, come do it this weekend. So the agreement is that you paint the house, the outside, and you'll get $200. And we do a spit shake. We each one of the spits on our hands and we shake on it and done deal. It's a contract, right?
Mm-hmm.
And so the agreement is that you're gonna paint the house, you're gonna get $200. Now, that's a contract and that can be considered an interface, okay? I never told you what color to paint the house. So you can go and pick whatever color you want to paint the house. So that's called like the implementation of the contract. It's like, what are the details? And a lot of times when you're writing programs, the details don't matter to a calling, from a caller. They just say, hey, I don't care how you do it. I just know that if I call this method, you're going to do something that I need, and that's all I need. So you're just going to paint the house and I'm going to give you $200, right?
Mm-hmm.
Based on that, what are you expecting when you're done?
Just a painted house, right?
No. But
I'm expecting $200. Yeah.
And how do you expect to get those $200?
By finishing up the house.
No. I'm saying like physically, how do you expect
Physically?
to get them?
in dollars, like actual money.
Money, right?
Money, yeah.
And that's where the details kind of are construed, because I can give you a prepaid credit card with loaded with $200.
Hmm.
Does that still satisfy the contract?
Yeah, it does.
I can give you a check for $200. Does that still satisfy the contract?
Yeah.
I can Venmo you $200. Does that still satisfy the contract?
Yep.
So you can see the implementation details, how they can be so different, but they still satisfy the contract, right?
Hmm.
So what he's talking about is that you can create an object, you can create any class, as long as it implements the interface or it implements the contract, IEnumerator. Is it IEnumerator?
Yeah.
Yeah. And as long as you implement that method, the details of how you implement that method, the for each doesn't care. Because the for each, what it's going to do is just going to go and change your code to something different. And it's just going to say, I know that there's a move next in here. And we're going to go ahead and just grab that next object that we have in the chain. What else do we got?
And then we are going to talk about casting and converting in between or between types.
Yeah, we
So,
can just touch on that one. So most languages that are high level are probably going to let you lose data. So we're talking like classic JavaScript. You know, JavaScript will let you convert from one type to the other, and it'll assume that you know what you're doing. Languages like C Sharp, Java, C++, all of those languages, they will not let you lose data. So if you have 1.5 and you say, hey, turn this into an integer for me, the compiler is not even going to let you compile. It's going to say, hey, stupid, you're going to lose that 0.5 if we switch it to an integer. So I'm not going to allow you to do that. You have to explicitly cast this. And the casting doesn't do any rounding. So if you cast 1.5, if you were to round it, 1.5, what does that round to? A
2.
2, right?
Hmm.
But when you cast it, it just says, okay, we're going to get rid of that 0.5. Here's your 1. You just lost a piece of data. The compiler will let you do it if you explicitly cast it. But in most cases, if you just say, hey, assign this value to an integer, I'll say, it's like, you can't do that. You're going to lose data. Don't be stupid. But it'll let you go the other way. If you're going to gain precision, like if you convert a 1 to a 1.0, it'll let you, because you're not losing data, you're actually gaining precision. Does that make sense?
Hmm.
So as far as the casting and converting and stuff like that, casting and converting doesn't do any rounding. It just strips out that piece of data that it doesn't belong to, into whatever you're casting it to. So if you're going from a decimal to an integer, you're going to lose your decimals and you're just going to get the integer part. And in some cases, that works. That may be what you want. In other cases, it may not be. And so it's very, you got to be very careful when you're doing that. I think he got into rounding after that, right?
Yeah. Yeah.
Oh, one more thing on the casting. He did cover min and max values for all the different types. So I think there's a byte, which is, what is it, like 16 numbers or something like that?
Hmm.
It goes 0 to 15. And then there's a small int, which goes 0 to, I don't know, I think 256, or I forget what, there's a table somewhere. Everybody mostly uses an integer. Nobody ever uses those other types, you know. But there's a min and a max to each one of those. So just because it's a computer and just because it's a numeric value doesn't mean that it's an infinite number the value that you can go to. There is a cap, and at a certain point, it's going to say, "Hey, this is as far as I count. I can't count anymore." And so, and there's also a minimum as far as the negative numbers are concerned. And so there's only so far that it can go. So that's one thing to keep in mind, is that numbers are not infinite in a computer. So there is a min and a max. So
Okay. Interesting.
yeah. People think, oh, it's a computer, let's just let it go forever, like new.
And then for rounding numbers, um, kind of like how do you describe that? Do you round up or do you round down?
Yeah. I always thought that there was no other type of rounding.
Yeah, I thought there was only one type of rounding too until.
I mean, what I learned in school, what they call preschool or primary school rule,
Mm-hmm.
is that anything 5 and above, it rounds up.
Mm-hmm.
Anything below a 5, it leaves it. It actually rounds, what they call rounds down, right?
Mm-hmm.
And so he talks about the banker's rounding, which I was like, wow. I go, that's crazy. What is it? For every odd number, it rounds up, and for every even number, it rounds down.
Yeah, for midpoint, so the point 0.5, that is odd, it'll round down, and round up if it's no, round up if it's past the midpoint, so point 0.5, and then round down if it's odd.
That's crazy. I've never heard of that. That's pretty bizarre.
That's such a weird way of rounding too. It's just,
Yeah. I mean, the reasoning makes sense, right? They didn't want to, what did he say? They didn't want to prefer one versus the other. And so this allowed it to be um, like, I don't know, I guess they pick and choose or something. That was
yeah, I
weird.
guess to make it random kind of thing.
Yeah. What was even more interesting is that the banker's rounding is the default rounding that C# has. You have to specify that you want primary school rounding, if you want the typical math rounding that everybody knows about. And so I was kind of shocked when I saw that. I was like, wow, I go, that's crazy. But I included a link in our notes that maybe you can include in the show notes,
Oh yeah.
talking about how to use the banker's rounding and normal rounding in C#. So yeah, that was something interesting that I learned today.
And then
Cool.
he goes into the opposite of toString, which is parse.
Yep.
Parse. And it has just a few types, mainly for date and time, just to display those.
Yep. And
Um,
also for numeric values.
and numeric values, yes.
Yeah, numeric values. So let's um let's do something with that. Let's go ahead and get rid of this code here, and let's start this method over. You can just get rid of line 9 through 21. Control X will get rid of the whole line.
Oh, all right.
So in here, let's do int I equals, and then the parser is int.parse. And then open parenthesis, and then inside of quotes, put in the number one inside of double quotes. Put in the number 100, and then end that line with the semicolon. And then in the next line is do a console write line. And then console right line the I. And then the next line, let's do another console right line. And let's console right line the get type to string. So it'll be I.getType.
I.getType.
Yeah, the get type always comes from a variable. And let's go ahead and run that. Now, you'll notice that on line 9, it's coming in as a string. So when you run it, it parses it.
Oh. And it sees that it's an integer.
And it parses it as an integer. So let's go ahead and go back to your program. I think if you leave this window, it'll just come up right here. Oh, did you close it?
Oh, yeah.
That's fine. Now let's put ABC in there.
Run it.
Run it.
Uh-oh.
Oh, it wasn't happy. Go ahead and continue up on top. Just press continue.
Where? Oh.
And then what does the output say? The console. Go look at your console. Open up your terminal.
It doesn't say anything.
Oh, hit continue again.
Oh, here we go.
Yeah. The input string was not a correct format. So that's the thing, right, that he was talking about, is that you have to have the right format in order for it to parse successfully. Otherwise, like, it's just going to barf on you. It's like, it's like it didn't like it. And so it throws an error, it throws an exception. This is what they call exceptional behavior. This is beyond what you expected. So he talks about the next topic to avoid this, right?
Yeah, the try-parse.
The try-parse.
So for try-parse, it would be more of kind of like putting the Boolean and the regular parse together.
Yes, absolutely. Nice.
So as a sentence, we would put this as a sentence, right? Or as a string.
Correct.
Cool. So how many letters are in the alphabet?
Sure.
And then,
but then you need to do the try parse, right?
Yeah. Oh, right here.
Yeah. Now, why is that red squiggly mark there? If you hover over it, what is it saying?
Bool int try parse character. So it needs to be a string right here, or one of these need to be a string, right?
Wait. Go back to the. So if you look, it says no overload for method try parse takes one argument. In other words, it needs more than one parameter inside the parentheses.
Okay.
And so what we need to do is we're going to put a semicolon at the end of I on line 9.
Mm-hmm.
And then get rid of the equal sign, and you're gonna put int try parse in a new line. And then after the second double quote on how many letters in an alphabet, you're gonna put a comma. So that means that you're sending in more than one parameter or more than one argument.
Mm-hmm.
And you see how it helps you with the syntax here. It says the syntax needs to say out. So type in out.
Int.
Not the int, is just saying that what you're sending in has to be an integer. And you just happen to have an integer on line 9, which is I.
Okay. So put I.
I, yeah. And what this function is going to return, you see how it says this is going to return a Boolean.
Okay.
So you want to put this int try parse inside of an if statement.
So I would write if.
Oh, go ahead and leave your I in there.
Oh, I.
Yeah.
And then quote or
No.
or just write it out.
No. Hang on. Stop typing for a moment. Get rid of your semicolon at the end of that line. Okay. And highlight that whole line right there, all the way down to the end. Highlight it and then do Control X. No, not that far, just to the end.
Just to the end.
Yeah, all the way to the end. Control Z. And then highlight the whole thing, including the end.
Oh.
And then Control X. So let's go ahead and type in if tab.
True.
And then paste in, no, go back into the true. You're going too fast for me here.
Okay.
Let's try it again. Get rid of that whole if statement. Let's try that again. Get rid of line 10. Okay, type in if tab. And before you do anything else, Control V. So what's going to happen is that try parse is going to give you a Boolean value. It's going to say true or false. I was able to parse this, or I was not able to parse this. And if you're able to parse it, go ahead and press enter. Press enter.
Oh, enter.
Yeah.
Right.
In here, do a console write line. And then just do I. Just type in I in there. And then if not, go ahead and put an else statement at the end of line 13. Put an else statement.
How?
No, else. No, get rid of that line. Control X. Get rid of that line. After the curly brace, type in else, E-L-S-E.
Oh, okay. Else.
And then tab again. Console write line. And then inside of double quotes, could not parse the value. Double quotes.
Double quotes.
All right, and then get rid of 18 and 19. So let's see what that does.
Could not parse.
So now you don't get the error, right? You get could not parse the value. So let's go back in there and let's put a 26 inside of double quotes.
In here?
No, line 10.
10.
Line 10. Yeah, instead of parsing how many letters in the alphabet, just put in 26.
Oh.
Or 10. Any number is fine. Play it.
26.
So now it successfully parsed it. So you can see within that if statement, it evaluated the true or false. I tried to parse this, and true, I was able to parse it. Or before, when you didn't have a numeric value inside those double quotes, I tried to parse this, and false, I could not. So that if statement evaluates the true and false, and it'll execute the what's inside the if. If it didn't meet the condition, if it gave you a false, it executed what's inside of the else condition.
All righty. Cool. Yeah.
Does that make sense a little bit?
Mm-hmm.
Cool. All right.
Yeah, and then he goes into handling exceptions for some of this stuff.
Yeah, he covered exceptions a little early in the book, I thought, but we're here, so we might as well go ahead and deal with it. So, okay, so what is an exception to you? What did you get out of the book?
um, I would say that an exception would be like something that has um like it kind of has two answers or two messages kind of thing. So like it would be like um yeah, just two outcomes that it could be. So like a before and after kind of thing.
Okay, all right. So yeah, so normally you would have you would have your normal flow of your program, right? And you would expect it to start at point A and go all the way to point Z and behave perfectly.
Mm-hmm.
It never fails. But what the exception handling does, it handles, just as the word says, exceptions, right? It's exceptional behavior of what your program is doing. If an error occurs, that's not what you expected. That's exceptional behavior, and you need to deal with it, right?
Mm-hmm.
So I actually have an example that I can show you. All right. What do you see on my screen?
I see the
Do you see login?
yeah, I see login.
And then you see the user here?
Yeah.
Okay. So this is an API call. And what this API call handles, it handles two things. It handles register and it handles login. And so inside this login, I have my try catch. And you'll notice that I'm catching two different types of exceptions.
Mm.
The first one is a login failed exception. The second one is just an exception, which is what any other exception would be. But you can see where you can catch individual specific exceptions, right?
Yeah.
And so what I'm doing is I'm saying, hey, go check in the accounts and log this person in. And if I get back a user, then I'll go ahead and return, hey, okay, you're logged in, right? But if for whatever reason they failed to authenticate, their login failed, I want to send back, first of all, I want to log this as a warning. And I say, hey, I got somebody that's trying to break into the system. So I log it and then I return a status code and I say, hey, here's the error that I'm getting. You have failed to log in. Any other exceptions, I just go ahead and throw 500 and send the message back and say, I don't know what went wrong, but I'm broken type of thing.
Okay.
And so this would allow the program to continue to work. They can retry to log in, and maybe they just fat fingered their password, and it'll allow them to be able to get back into the game instead of just the application just breaking and stop working. You know what I
Okay.
mean?
Yeah, that makes it
Does that make sense?
understandable. Yeah.
Cool. So there was a couple of puzzles that they had at the end, but there's one in particular that caught my attention, and it's called Fizz Buzz. And so it's a popular programming interview question where they tell you to output fizz for every number that's divisible by 3, and every other number that's not divisible by 3, output buzz. Were you able to do the puzzle?
I looked over it. I didn't do it myself though, but yes, I did look over it.
Oh, let's check it out.
This FizzBuzz example will be posted as a separate video from this podcast. Be sure to check it out. Link in the description.
All right.
All right.
We'll see you next time
On the next episode of The Road to Code.
The Road to Code.